Okay, so this is an example of a longer problem that we might do in design and measurement. A lot of design and measurement questions involve some sort of choice for you. So you get to sort of make a decision about how you want to, as the unit name suggests, design whatever it is that we're working with. So in this example, we're talking about building a sandcastle. And so we have pails in the following shape. So we've got a cube that's 12 inches by 12 inches by 12 inches. We've got a cone that has a diameter of 6 inches and height of 11 inches. And then we've got a cylinder that again has a diameter of 6 inches, and this one has a height of 9 inches. It just notes that it's not drawn to scale. That's because this is 12 inches, but this is 6 inches. But they don't look like, they're not relative to each other is what it's saying. And so you're asked to design a sandcastle. You only get a 2 foot by 1 foot area to put it on. So they're giving this measurement in feet. All of these measurements up here were in inches, so we're going to have to do some conversion at some point. You need to use each thing at least once. You need to use at least 5 different, not really shapes technically, but of each object. But you don't have to use each one 5 times, you just have to have 5 total, at least. And it can't go more than 3 high. So I made this little sandcastle. It doesn't, you can make your own. This is just an example that I wanted to show you of how we would work through a problem. So, first of all, this is 1 shape, 2 shapes, 3 shapes high, so that's correct. We can't put it more than 3 high, but exactly 3 is acceptable. And then it uses at least one, each one at least once, yep, because I have a cone, I have a cylinder, I have a cube, I have a cylinder, I have a cone. Yeah. Anyway, so each one at least once, we're good. I used 6 pieces to make mine. I have a cube and a cube, a cylinder and a cylinder, a cone and a cone. So I have 6, which is more than 5, because the minimum is 5, so you can do more. And I know that this fits in a 2 foot by 1 foot space, because if I go back up here, I know that 12 inches is 1 foot, so this is like 1 foot by 1 foot by 1 foot. So if I put 2 cubes exactly side to side, they'll be 2 feet long and 1 foot wide. So this takes up the proper amount of space. You could make it smaller, like it has to fit inside the space. So if I just wanted to use 1 cube, I could just put some more cylinders and stuff down here if I wanted to. Okay, so again, I'm just going with the example that I drew there. But this is not the only correct answer. There are multiple correct answers. This is just one of them. So for part B, we're asked to calculate the volume of sand required in cubic feet to build your sandcastle. So once again, they gave us all our measurements in inches, but we're now asked to find the volume of sand in cubic feet. So you'll notice on your notes, I say that you can convert inches to feet before or after calculating volume. However, you just have to be careful that you're calculating correctly for whatever step you do it in. I very often do it at the start, but again, it doesn't matter so long as you're keeping it straight like what you're doing. So if I want to calculate the volume and I want to convert inches to feet first, what I know is that there are 12 inches in 1 foot, so I'm going to take all of my inches and divide by 12 to figure out how many feet that is. So for the cube, that's really not terribly difficult. It's 12 by 12 by 12. So that means it's 1 foot by 1 foot by 1 foot. So here I've got 12 inches equals 1 foot, and then the volume of a cube is length times width times height. Well, each length, width, and height are all 1 foot, so I'm going to go 1 times 1 times 1 is 1 foot cubed, or 1 cubic foot. So that's how much it is for 1. However, I have 2 cubes as part of my design, so if one of the cubes is 1 cubic foot, then 2 cubes would be 2 cubic feet. So that's dealing with the cubes. Then I also have the cylinders and the cones to deal with. So again, doing it this way, I'm converting first. So the first thing I'm going to do is actually look at my diagram of the cone up here and notice that they've given me the diameter, but if I'm looking ahead and looking at those formulas, they all use radius. So instead of converting the 6 inches, I'm going to first divide the 6 inches by 2, gives me 3 inches is the radius. And then I'm going to take my 3 inches and divide by 12 to get 0.25 feet, or a quarter of a foot. And then I've got my 11 inches in height. So again, I'm going to do 11 divided by 12, and that just gives me 11 twelfths. I don't want to round that, because remember, we want to keep all of our decimals in our calculations until the end. So I'm not just going to punch 11 twelfths into my calculator and then do that, because that would be 0.916 repeating, so that's 0.91666666666 forever. But if I rounded that, I would probably round it to 0.92. Again, I don't want to do that until the end. So instead of using 0.92, I'm going to just use the 11 divided by 12 in my calculations. Okay. So so then for the cone, first thing I'm going to do is look for the formula for volume of a cone, and that is pi r squared. So pi times the radius squared times the height divided by 3. The divided by 3 comes from the fact that it comes to a point, and that's just sort of how things that come to a point that way work. So pi, again, you should use the pi button on your calculator. The radius we figured out was 0.25 feet, so 0.25 squared. And then again, I'm using my 11 divided by 12, not that decimal number. Multiplying all those, divide by 3, and I should get 0.06. So that gives me 0.06 feet cubed for one cone. I, however, have 2 cones. I'm going to lay them up here. So I have 0.12 cubic feet for the 2 cones. And then I need to look at the cylinders. Again, I'm choosing to convert first in this case. So I've got my 3 inches, and that's equal to, because I'm again looking at that cylinder, it has a diameter of 6 inches, so I need a radius. So again, radius is half diameter, so that's why I'm using the 3 inches. That's where the 3 is coming from. And so 3 inches is still equal to 0.25 feet. And then so 9 inches is 0.75 feet. You can use a converter for that, or you can just divide by 12, whatever makes you happy. So then volume of cylinder is pi r squared times height. So I'm going to use that formula and I'm going to fill in these values. And that gives me 0.15, so that is a rounded value. So that is the rounded value for a single cylinder. But again, I've used 2 cylinders in my castle, so I'm going to multiply that by 2. I'm going to double it. And when I do, it's going to give me 0.29. That's because I kept all of the decimals, like 1.15 is a rounded value, but I'm not going to round my answers until I'm done. So I'm just leaving all the decimals in my calculator until I'm done all the calculations. So now I have sort of each piece individually. I have the cubes, the cones, the cylinders, and I just need to add them all up together. Also, I'm sorry, I know the notes look kind of rough. Our photocopier is not super doing well right now. So that's why it looks kind of weird and terrible, and I'm sorry, but I couldn't fix it. So we get our total volume is 2.41 cubic feet, and that's what we've been asked to calculate for this one. If you were calculating, so I did the example out on the other side of your thing there, where you're calculating everything in inches first and then converting. What I would actually suggest if you're doing that is two things. One is that you find your total in inches, in cubic inches first, and then just convert the total. So I think you'll probably run into less of a problem in terms of like keeping decimals and stuff like that, which is not exactly how I did, so I apologize. So just the formulas are all the same. So you just use the same formulas, plug in all of the inches, and then after you've got that done, like I said, just find the total. So just add them up. So yeah, again, that total is just 2 plus 0.12 plus 0.29 gives you 2.41 cubic feet. So like I said, if you're doing the inches, you're gonna get way more than that. And then use a converter, but make sure that since you have an answer, like the total volume you'll have will be in cubic inches, you want to turn that into cubic feet. You can't just go straight like linear inches to linear feet. That's a different conversion. So find your total in cubic inches first, and then convert to cubic feet. And again, make sure that you're using the proper units when you're converting, when you're doing that. Or you can just do it the way I did it here. Whichever way, you should still get exactly the same answer. And then the last step just asks us to calculate how much our little sandcastle would cost. You'll notice that they specifically say that you don't have to use whole units. Alright, so it says the organizers purchased sand for $1.11 per cubic foot. We want to know how much that means that the sand in your particular castle, so this particular castle example that we used, is worth. Again, it says assume whole units do not need to be used since the sand has already been purchased. So what that means is typically in these types of questions, if it comes out that you need, like if you're buying something, typically you have to buy it in whole units. What that means is if you're buying cans of paint, typically they're not just going to let you go to the hardware store and be like, yeah, I need 2.5 cans of paint. They're going to be like, cool, you need 3 cans of paint then. Like that's just how things work. And even things like flooring and stuff might come in like certain batches or like a certain amount. They're not going to be just cool with you being like, I need exactly 2.54, feet of flooring. They're like, cool, you figure your life out and then come back and see me. So this is different though. This is saying that the organizers already like bought this stuff, and so they're like, you're just trying to figure out like how much of like the sand they bought did you like use. So if we use 2.41 cubic feet and each cubic foot costs $1.11, we're going to multiply those and get $2.68. So your little sandcastle, or the little sandcastle that I made actually, uses $2.68 worth of sand.